In this video, I'm going to demo drawing a square with an area of 18, which is trickier than drawing a square with an area of 9, where that would mean that each side length would be 3. So we have two whole numbers, 3 and 3, they're identical, that multiply to equal 9, and 9 is one of our perfect squares. 18, however, finding two identical whole numbers that are going to multiply to equal this, and in module 5 we learned perfect squares and we know that 18 isn't one. So to draw this, like the first video in the slide with square ABCD, we're going to have a um, tilted or rotated square. And it is going to be a perfect square, and we're going to have to do a little bit of trial and error with this. And what we saw with the tilted or rotated square was that on each side, we had some right triangles. Okay, so we currently have a square where we can see that the slope, if this were on graph paper, would be 1, -1, 1, and -1. So it definitely has that parallel and perpendicular, as well as we can tell that all the sides are equal because these right triangles are all equal. And the area of the bigger square, 2, 3, 4, 5, 6, is 6 squared. And what we're going to do is we're going to take away the 4 right triangles. And if we didn't get the 18 that we were after, then maybe we will make the overall square slightly bigger or smaller to accommodate for this. We have 4 times 1/2, and the sides are 3 and 3. So we have 36 minus 4 times 4.5, which leaves us 18 square units for the inner square, which means that the side length, as we have starting to come to see in this lesson, is going to deal with the inverse operation, which means that the side length of this is actually number root 18, which if you type it in a calculator is going to give you a pretty nasty decimal. And so the process was, as you try the other ones, if you notice that you don't have a perfect square, you're going to have to rotate it within another square and try to find some configuration that when you either break up the inside or the outside, you get the desired area.